Good day, everybody. My name is Achayem Chidera Destiny, and today I'm going to be talking about the real-world applications of offensive security techniques. And we're basically going to be talking about penetration testing and everything that concerns it. My name again is Achayem Chidera, and the objective of this is to showcase how offensive tools and techniques learned in ZX301 can simulate real-world cyber attack scenarios and enhance understanding of attackers' tactics and inform better defense strategies. Next up, we're going to talk about why offensive security. So there's red teaming, there's holistic cyber security, and there's obviously a motivation for it. So the red teaming basically replicates attackers' mindsets for better defense. Holistic cyber security basically combines offensive and defensive skills, and then the motivation is basically just simulating threats and assessing resilience to prepare for APTs. Right. So the whole thing that we're talking about in this presentation is penetration testing. And penetration testing is basically a simulated cyber attack in order to strengthen a web page or basically systems security. That's the whole point of it. So it has to be done legally, and the whole purpose of it is to strengthen security. Right. Now, the first thing that you want to do is information gathering, which is the first lab that we discussed. Information gathering is the first phase of penetration testing or ethical hacking, and it's the stage where an attacker, which is the ethical hacker in our scenario, collects data about the target system, organization, or the network without direct interaction or causing harm. This is basically called passive scanning. What you're trying to do is gain information about the organization or system that you're trying to attack. In order to do this, you have to passive scan at first, right? And we use tools like the Harvester. We basically collect emails, subdomains, hosts from search engines. Next tool is Whois, retrieves domain registration and ownership details. There's NSLOOKUP, there's Recon NG, and all of these are tools for passive scanning. You're trying to gain information, you're trying to gather information about your target system, right? And in this star use case, star stands for situation, task, the action, and then the results. So that's the use case that we're going to be using for the whole of this presentation. So S is the situation. So in this situation, the red team is red team assessment of a fintech startup. That's what is going on. And the task is to identify external digital footprints. And then the action is that we're using Whois, NS lookup, the Avesta, Recon NG to gather this information that we're talking about. Now, an example of the command that we'd use is the Avesta-D, and then the fintech company. You can't, this obviously, this is not the name of any company or anything. It's not really a domain. But in order to use an actual domain, you have to get legal permission because it's illegal to be doing things like this without permission, right? So let's say it was CUDA, so it would be CUDA.com or whatever fintech you're trying to like talk about in any scenario they're using, and then hyphen B Google.com. So the result would be we found exposed dev subdomain, staff email format, and all of that. Next thing we talked about is scanning. So this scanning that we're talking about is active scanning instead of passive scanning where you not necessarily interact directly with the system. This active scanning is you're basically sending probes or you're basically just interacting with the system in order to gain information, discover open ports, closed ports, filtered ports, things like that. So scanning is basically the phase of penetration testing where the attacker actively probes the target system to identify open ports, services, live hosts, and potential vulnerabilities. Tools that we use in this is Nmap, Marscan, Netcat. These are just some of the tools that you can use, and all of this is basically just for scanning, right? In our star use case, we're saying the situation is we're trying to identify services on a misconfigured AWS server. So the task is to find the open ports and the versions, right? And in order to find versions, you have to use flags like -sv, and just these are just flags that you use to gain extra information instead of just finding like the open ports. And then the action is we use nmap and marscan, and then obviously this is the command that we're using. So we do nmap -ss -sv for the version, -p for all of them, and then this is the IP address, right? So the results here is that we detected that the Apache port 80 is port 8080 with vulnerability. So if you see that one is open and is vulnerable, that's where attackers can basically like infiltrate your target system. And that's what we're trying to discover, trying to find the leakages or the vulnerabilities, if you will, in your system, your whole system. So scanning bridges recon and attack. So accuracy is crucial. It's crucial, sorry. Um, Enumeration is the next thing we talked about in our third lab. Enumeration is the process of actively connecting to and querying a target system to interact to extract detailed information such as the username, the shares, the services, the system details. The purpose of this is to identify the valid user accounts and discover shared resources or files. So this is basically still gathering information. All we're trying to do is just gather information about this our system. Now the tools that we use in this is enum for Linux, which is basically enumerates the SMB shares and user info. SMB stands for server message blocker. And there's SMB clients, which is accesses the SMB shares from the Linux terminal, and Nikto, which is web server scanner for vulnerabilities. So the purpose of this again is to identify valid user accounts and discover shared resources. Right. Now we're going to talk about the use case. So the situation is basically we assess the internal network via VPN connect and notice the SMB. So the task is to gather shared files and credentials, right? And then the action is that we're using enum for Linux and subclients. So this is an example of the command we'd use, and the result would be retrieve usernames and PDFs with passwords and all of that. So once you can do this, you know that the system that you're attacking is vulnerable. Now, exploitation. So exploitation is the phase in which the attacker takes advantage of the discovered vulnerabilities to gain unauthorized access, execute code, or escalate privileges on the system. The whole point of um attackers attacking your system is basically to gain control or escalate privileges so that they can gain information or credentials or things like passwords and usernames, things like that, just to like attack your system. And what we are doing as penetration testers is to simulate these attacks so that we will identify what the problem is and the things that the attacker will and will not be able to do. So we'll find a way to mitigate it legally. Very important. So again, the star use case. The Apache service, the situation is that the Apache server is vulnerable to CVE 2021-41773, and then the task is to execute the commands remotely. So, the action is that we created a payload with Metasploit and then curl, and then the result is that we gain unauthorized access and extracted file. So, we're trying to extract information from the etc/password. So that's basically where all the hashes for your passwords are by using the call command. This is basically an example of an exploitation. What the attacker would do. Remember, it's a simulation, so this is something that the attacker can do once they are connected to the vulnerable ports or anything. Right. Next thing is the Metapreter. So the Metapreter, short for Meta Interpreter, is a powerful post exploitation tool built into the Metasploit framework. It basically gives the attacker an interactive shell on a compromised system, allowing them to um stealthily control and explore and exploit a machine, right? So, firstly, is the star use case is obviously what we're going to be talking about. We have been discussing this since. Now we gain access to a compromised window box, and then we maintain access and performed internal recon, and then we launched a metapreter. We dumped hashes and then webcam snapshots. So these are basically things that the attacker can do on the Metasploit framework. The Metapreter, sorry. So the result is that we extracted NTLM hashes and visual confirmation. So um an example of a command that can be done is we'd use exploit multi-handler, which is obviously a module, and then we set the payload Windows Metapreter reverse TCP. This is a staged payload, and then we run it and basically just like execute commands and all of that in order to gain information. So we're basically just checking out what the attacker can do again. Now, payloads. Payloads are the actual code executed on a target system after a successful exploit. So they provide a way for the attacker to interact or control the victim machine. In order to gain access into the system or something like that, you need to create a payload. We can use MSF Venom to create a payload, and then you would be able to um actually like send it to your victim, and then your victim clicks the link, and then once they click the link, you get access into it by creating a listener, and then basically you can just like listen and do whatever you want. You take snapshots, I mean screenshots. You can just do whatever you want once you've created the payload and the user has access it. So there are types of payload, right? There is the stage payload and there is the stages payload. So the stage payload is um sent in multiple steps, right? So it's small initial loader to full payload, and then it's smaller and more stealthy, right? An example of a stage payload is Windows Metapreter Reverse TCP. And then the stageless payload is sent as a complete binary, so it's faster to execute, but it's larger and easier to detect. So the two main difference between both of these is that the stage payload is bigger, and the stageless is, I mean, the stage payload is lesser in size, and then the stageless payload is bigger, right? And the stage payload is basically when you're prioritizing stealth, right? While the stated payload is basically just for like for speed, and it's just faster to execute, right? So this is an example of a stageless payload. You can also identify them by you see a forward slash in the stage payload, but you see another score here. Now the situation is the red team simulated hybrid cloud attack, right? And the task is to bypass antivirus for remote control. And the action is that we generated encoded payload with MSF Venom. Okay, so the example of the command that we're using here is MSF Venom -p. Then we input our stage payload, and then the L host is basically our IP address. The port is the port that we're trying to use, and then F is the type of file. This is an exe file, so it's an executable file, and then the name of the file is the shell.exe. So once the victim accesses and maybe like runs it on their system, they would we would gain access into it. Right. Next thing we're going to talk about is post-exploitation. Post-exploitation basically refers to the phase after gaining access into a system where the attacker collects information, they maintain access, they escalate privileges, or move laterally to other machines on the network. So basically what the attacker can do once they have gained access into your system. So once they have gotten a listener and they are just in there, they can just basically get any information that they want. They can input commands like get UID to show current user, system info to display OS system info, get system to try and escalate privileges to system, hash dump, dump password hashes, and all of this. Webcam snap, shell persistence to install backdoor for future access. Now, the star use case. So post access to internal domain server is the situation, and then we're trying to gather information and escalate privileges. And then the action is to get UID, get system, and my makeouts, which is basically a different tool. So the result is that we gained the domain admin accessed database, right? So Metapreter obviously is the tool that we're using. We get system Metapreter, we load Kiwi Metapreter, and then create. Also, the insight is that the post exploitation provides valuable intelligence. Let me explain what this command does. So here's what the Metapreter command does. Get system basically attempts to escalate your privileges on the target machine to the highest level, right? So giving you full administrative control. Then the load Kiwi basically leads the Kiwi extension inside Metapreter, which is a tool that helps extract Windows credentials. And then there's Quetzal, which uses a Kiwi module to dump all cached credentials, hashes, and plain text passwords available for compromised systems. Um, Social engineering. So social engineering is basically a technique that manipulates the human psychology rather than technical vulnerability. So to gain unauthorized access for information. Basically, what attackers do, things like phishing, spear phishing, pretexting, baiting, it's just like psychological ways attackers can manipulate their victims in order to gain access into your system, like pretending to be um a trusted entity and having the victim click on some kind of malicious link so that they can gain access into the victim system. So once they click this link, they would be able to manipulate and send commands and just extract information that they want. That's what phishing is. Spear phishing is basically phishing, but with a targeted person. Phishing is basically just sending emails to like a bunch of people, but spear phishing is having a target in mind, like a target organization, a target individual, like just one person or maybe two people, just having a target. There's baiting, which is basically offering something enticing like a free USB to lure the victim. And then tailgating is basically physically following unauthorized personnel to restricted areas. That's what tailgating is. Now, the tools used in social engineering is set toolkits, which creates phishing pages and payloads. There's Goldfish, there's Kingfisher, there's Multigo. All of these are tools that are used for social engineering. So we're going to talk about the situation, the task, the action, and then the results. So we simulated a phishing against the HR staff, right? Task is to capture the user credentials, and then the action is we cloned OR login. So we sent phishing emails. Now the result is two user submitted credentials, right? So once we've created the phishing um email and send it out, there'll be people that would click this link and then we'll get all the information that we need. Keep in mind, all of this has to be done legally. You can't do this illegally. Web application security. So web application security involves identifying and fixing vulnerabilities in websites or web apps to prevent unauthorized access and data breaches. So attackers exploit weaknesses like input validation errors, authentication flaws, and insecure configurations to compromise applications. Now, common web application vulnerabilities are cross-site scripting, which is basically injecting malicious script into web pages. There's SQL injection, which is basically manipulating database queries inside the user inputs. There's IDOR, there's broken authentication, there's security misconfiguration. So basically, web app security is basically just maintaining security of the web application. And the web applications can have multiple vulnerabilities, like I just mentioned, like the SQL injection is basically just a vulnerability that allows the attacker to inject malicious SQL code into their queries and manipulate the database and just gain information, right? And now the situation in this scenario is we tested a ticketing system for common OWASP flaws like injection. And the task is to check for XSS, which is cross-site scripting, SQL injection, and insecure direct object access. The action is that we use Bob suits and custom payloads to inject malicious scripts. So the result is we found persistent XSS and unrestricted sensitive data access. So the web application is the common target. So proper sensitization and strong access controls are critical for defense. So the whole point of this whole thing is to find vulnerabilities and then fix them, right? Now, the lessons learned and the challenges. So the challenges faced is crafting payloads to bypass modern AV. So you can't just like create anyhow payloads in order to bypass modern AV. So you have to be creative and just craft them, right? Avoiding detection during stealth scanning, escalating privileges in hardened environments. And then the lessons learned is that offensive exercises highlight defensive gaps, right? You don't once you perform all these tasks, you understand that it shows you the flaws in a system, right? So thorough enumeration boosts exploitation success. The whole point of enumeration is to gain information like the user accounts and all of that. The OPSEC is vital for realistic simulation. And then the final takeaway is that offensive methods mirror real threats, and this enhances defensive capabilities. um, the key red team tools include Metasploit, Burp Suite, and SCT. And then the ethical conduct. Basically, all engagements must adhere to strict legal and ethical guidelines and then enhance defense. So simulation strengthens detection, response, and user awareness. Thank you. If there are any questions, you can ask. My name is Achoyem Chidera from Think Cyber.